now let's move on to the final presentation of the day. I would like to warmly invite Dr. Viet Pham. So before I invite him to deliver his talk, I would like to give a brief introduction. So Viet Pham is currently an associate professor in network and distributed systems at the School of Computer Science and Statistics, Trinity College, Dublin, Ireland. He earned his PhD degree with the Best PhD Dissertation Award in Telecommunication Engineering from INJ University in 2017. He has special research interests in the areas of wireless AI, edge computing, Internet of Things, and distributed machine learning. He was a recipient of Clarivate highly cited Research Award in 2024 and IEEE ComSoc Best Young Research Award for EMEA 2023 in recognition of his research activities for the benefit of the society. He is currently serving as an editor of IEEE Communications Letters, Communication Standards Magazine, Communications Survey and Tutorials, Transactions on Mobile Computing, and Transactions on Network Science and Engineering. Over to you, Dr. Viet. Anything you prefer.
Okay, yes. Oh, maybe I see it. Okay, so as let me share my screen. Can I ask the people? Can you see my screen and hear my voice? Okay. Okay, so I thank you to all the people in ENSURE-6G and the host for organizing this workshop. Also for introduction to my profile. So I'm Viet. I'm currently working as assistant professor in Trinity College, Dublin. So today I'm going to briefly discuss and share my recent research on machine unlearning. So that's a new way for us to rethink how we can forget, how we can protect our privacy or something like that. And before that, let me give a brief introduction to Trinity College, Dublin. So our university was established around 434 years ago. And we are in the center here. You can see we are in the center of Dublin. So yes, here the islands and Trinity College Dublin is in the center of the capital. I think it's around 10 kilometers from UCD. So UCD is out here, right? So in terms of the QS rank going 2026 and 2027, so we are ranked 75. So we have 3 faculty, 23 schools, and we also host of some research centers. Previously, we are host. My school is it hosts up to research centers on AI and telecoms, and we are now also host and the leader of some new research centers on AI as well. So I think some of you have visited the Trinity College Dublin, so you could see here that is the temporary opportunity. And I will also use that photo when I describe and when I explain my research. And this is a book of chaos. So hopefully, if you have time to do secondment in Ireland, so feel free to drop by Trinity and visit these places. Okay, so that is just a brief information for my research projects in my group. So I'm currently a coordinator for one choice era project on the interplay between distributed learning and smart contracts. So we started the project in September 2025. I think we have the same timeline with ENSURE-6G. I'm also a co-I and a PI for some other projects on something like the use of generative AI for machine unlearning and the combination of quantum AI and vector learning, and then use the framework to optimize the physical layer in 6G networks. So my group is consisting of several PhD students. Some of them are funded by the Research Island, by Mercury, by Innocis, and I'm also supervisor for some visiting student and one master, one research by master student. Okay, so this is the very first slide for my talks. So you know that for nowadays we talk much about AI, data, distributed computing. I think one of the main reasons is that now we have data everywhere and every time. So something like, okay, we have a new iPhone every year. We can use the bank to, we can do payment online when we do shoppings. We can use something like WhatsApp, WeChat, we can do bank transfer online. Okay, so we can play game online, right? And then something like we have CCTV. This could mean we have data. And then we need to transmit the data between the device. We also need to share the data. We need to collect the data. We need to process the data. I think one of the main motivation for AI distributed computing is 6G. Sorry, I think the main focus for our projects, right? So my research is strongly linked to data circulation and nicheization. I think the main motivation is enactment of some new laws like CCPR, GDPR, right? Also, we have EU AI Act that was effective from around 2024, and in EU AI Act and GDPR, one of the requirements is that we need to, to guarantee the right to be forgotten for the end users. It could mean that we need to guarantee that the end user has right to request the provider to, to remove their data. Nowadays, we use our mobile phone, we use the smart devices, we install the applications, and okay, so it could mean we share the data with the providers like Google, right? But in some cases, we don't want to share our data, or we just want to remove the application from our phone. This could mean we don't want to use that more application. We don't want to share our data anymore, even we share our data with them before. And that's where machine learning step in. So the machine learning is a key concept I think that is similar to machine learning and AI and machine learning. So, and one of the key concepts is the data erasers or the right to be forgotten. So here you can see, okay, so that is just a capture from my phone to show this is the concept for vector learning. And if we go further, so something like that. So I want to delete my data. I want you to delete my data from your models. So that's it would mean that machine learning is very good additional to some existing technologies like vector learning, right? We want to guarantee the end-to-end privacy for the end users from the time we collect the data, from the time to we process the data to train the local models, and to the time we need to remove the data after the model has been deployed in practice, right? So in machine learning, so one of the critical question is how does client know that their data influence has been removed. It would mean that, okay, so we have a questions. We send a request to, to the providers, right? Okay, so they promise us they can remove our data. So the influence of our data has been removed, but in practice, there's no way for us to judge them. How there's no way for us to verify whether or not our influence has been removed from the model. So based on just motivation and to arrest existing gaps, so we propose a just by design veterinary frameworks. So that work is done in collaboration with two partners in ENSURE-6G. So during the secondment of my PhD student to Delft. So you can see that's a very long process when we have some advancement in AI and machine learning in deep learning. And we have the concept of federated learning in 2015, right? And the concept of federated unlearning in 2020. Okay, so we expect that. So this may be 2024 forward. So we need to make sure that the federated unlearning concept and methods can be deployed in practice, but also they can well verifiable. So that's our main focus here. And in this, we aim to provide the answers to the 5 questions: who unlearn, who verify, and what goals can use to verify that. Okay, so our model has been done. So how to verify? So we need to make sure that unlearning is done successfully. And we also need to make sure that any people who are affected by our request. So this could mean that in that position paper, we try to provide the answer to these 5 questions, right? Okay, so we have a lot of information here. Okay, so you first of all, just one example, the answer to the question is who perform an unlearning. So from the architecture perspective, okay, we think that as an end user, we want to, we want to send a request, we can perform unlearning. Of course, the service provider and the central server can perform that. And if we are third service provider, so it could mean that we are also able to perform unlearning, right? And the third party can also join the process as an auditor, right? So we have some more metrics now. Okay, here I think is we have a long list of the metrics that we can use, but you know that there's no single metrics that we can use. So it could mean that somehow we need to combine some of them, and we may need to propose a new metrics because you know that the regulation may change in the future, and we need to adapt the metrics to, I would say, to meet the requirement from the regulation and laws. So we combine our answers to a single frameworks, right? So you can see we do some steps. So who performing the unlearning and what goes and how to perform and how well it is. So we try to combine all of them into a single frameworks. Yes, and I think that position paper on verifiable federated unlearning is very first step for us to do more research because that area is new and more works need to be done. Right. Okay, so and now I would like to share one of my work on federated on server unlearning. So before I go to details, I would like to give the credit to my former student and also to some colleagues from two universities, one in Vietnam, one in Australia. Yeah. So you know that we have a couple of methods to perform unlearning to do the forgetting. I think one of the naive approach is that we retrain the model from scratch. Okay, it would mean whenever we send a request to the service providers, so we can retrain the model from zero. We can also try to approximate the process But you know that the very first layup retraining from scratch is mostly impractical. Because think about because you know when we talk about pattern learning, we talk about distributed end users, and we talk about the system that may contain 100 end users, 10,000 end users, even 2 billion end users. So that's quite impractical, right? And for approximate unlearning, that's very fast to perform, but is narrow to some scenarios and may poor perform in some scenarios now when we need to unlearn the whole contribution from some clients. So this is why I said in the beginning I want to use carefully. I think that's in the how to say that's in the key, one of the key when we talk about the Trinity, that's the Camperly. So you see, so we know that is the bell tower, that's the figure, that's the representation of Trinity. So when we go from C to B, I try to reduce the quality of the figure, right? You can see it's a little bit blur in B, and then in A here you can see it's very blur, low quality, right? Even we could not see that some people here, right? We could not see. So we just know that's the people. But maybe if we have the how high quality figure, if we zoom in, so we could see clearly who they are, right? But even the quality of the figure is much lower. We can still see that's the company of Trinity. I think something like I think all of the people in these rooms and all the people maybe who are online know that's we are trying to we are doing these workshops from Sri Lanka, right? It's good mean it's very hard for us to remove your knowledge that this workshop is organized in Sri Lanka, right? And something like that, if you are student in Trinity, so you know that even the quality is good or bad or so. We know that's the company. So based on that motivation, so we try to discuss, we try to debate that we can split the model into the causal and non-causal models. So for the causal, it's good mean that something stable, something on all of us know, right? Yeah. So we know that this presentation is a part of ENSURE-6G workshops. We know that, and Dublin is the capital of Ireland, right? So and then the second part is non-causal feature. That is something invariant, something that is not specific to the own client, something that's specific just to some clients, some users, right? So I know our data, you know our data, you know our family, something like that. That is something just aware to some of you, but not aware to all the people here, right? So based on that concept, we debate that invariant components are less sensitive to the data to removal. It could mean that something like Dublin is capital of Ireland is not sensitive to removal, right? I think that's we can say it publicly. Dublin is the capital of Ireland, and change they call it Dublin TCD and UCD are two universities in Ireland. That is something we can say publicly. We don't need to remove them, right? It could mean invariant components are less sensitive to removal, and thus they require minimal adjustment to the model. So that's our main our main motivation for the method we propose. So based on that, we propose a new principle in Unlearning. So it could mean that when we want to enhance the performance for Unlearning, so we need to make sure that the goal of Unlearning is to reduce the information encoded by the non-causal featureizers or model. So here you can see, so we try to decompose our method into two process, two stage. The first one is prepare to unlearn. When we try to make sure that the data can be learned to be non-causal or invariant or variant. And the second stage, when we perform the request, so we need to syntax what we need to unlearn, right? So that says, okay, so we need to only to decompose or disentangle the model into need to unlearn or not need to unlearn, something like that. I think if you are learning machine learning, you learn concepts more how to encoder. So we have the encoder, right? And the decoder. And here we see we develop the one encoder for invariant and one encoder for invariance. So the objectives are quite different. The first one is enforce invariant representations. And the second one is to enforce the variant, invariant, and the variant. We do two objectives, right? Okay, so, and then one more thing is that, okay, when we are able, we can do disentanglement, the decomposition to not need to unlearn or need to unlearn, or say the sensitive data. So one of the challenges is that when we deploy them in practice, because you know that in concept perfected learning, so we have a lot of clients, maybe 10, maybe just a few, but maybe up to million to, I'll say 2 billion. So one of the challenges is that very hard for us to align the guidance on the servers. It's good means that how we make sure that all clients agree on an objectives. If we are just two people, so maybe we just talk to each other to agree on an objectives. But if the system scales up, right? So it's more and more challenging for us to agree on an objectives. So in terms of the machine learning, so we talk about the gradients, right? So that is where we do our techniques on our server matching of the gradient. So I think that's a long list, but I just want to show the concepts. Okay, so our concept is quite minimal. I think that is something we learned in high school. We just use the concept for cosine and sine because you know that when the angle is 0, the cosine is maximal, right? When the angle is 90, the cosine value is minimal, is 0. So based on that, so we just try to minimize the gradient angle for Z10 clients and maximize the gradient for forget clients. You know, when we maximize the gradient angle, so we expect that such angle can be 90 degrees. So when the angle is 90, so gradient for forget client is 0. So when the value is the cosine value is 0, so it could mean that the influence has been removed from the model. The same here, we expect that the gradient angle for D10 clients is 0. So it could mean that we want to retain the whole knowledge. So we don't want to lose any knowledge from the D10 clients because they want to stay, they want to continue using the application, right? So in terms of mathematics, so we just do the minimization and we do maximization here because that is the minor size, right? That is our main concepts. We want to explore very simple concepts from high school, just a cosine or sine value, and then we combine them into a single objectives or joint optimization problem. Okay, so this is where we show that okay, our methods can perform well. Okay, so because you know that our method is two-stage, so we show that when we combine both of them, or just the first stage, so we can outperform on the existing methods. Okay, here you can see that the remaining accuracy is very high, while the, how say the relative approach and the existing methods is only around 82%, right? And on another data set, here you can see our accuracy is still higher than the benchmarks. They are only around 41, right? We are 42 or 44%. Even it's good means that even we train the data sets, so our performance is still much better, right? So this is the main concept. Because you know that's the motivation for our method is based on the cosine values. So traditionally here you can see that there's no difference between the retain and the forget glance because we try to optimize all of them. Right? There's no difference. There's no distinction between the retain glance and the forget glance, and that's why you can see the angle here are the same, right? That's why the cosine value is the same for forget glance and for Zeeman glance. You can see in our method, we try to maximize the gap between retain glance and the forget glance. That's why you can see that the cosine value is increased here. In some cases, you can see we can achieve the gap around 3.35 after around 100 and 150 steps, right? And the same here, you can see the gap is quite high compared to the gap here, right? They have the same performance. And here the gap is minimal, but in our methods, the gap is very large between the clients who want to detain and the clients who want to leave the networks. Okay, so that's it, just a comparison. So here are some insights. For the fast retraining, okay, the performance is good, but you know that the time needed to unlearn is very high. And again, the computation resources is high. And approximate unlearning, okay, so because we say approximate is good means that it's very fast, but the performance on accuracy is very low. Our methods, when we combine the concept of learning to unlearn and we combine with the alignment on servers, so we could achieve very consistent performance on the baselines. Okay, so that's the end of my presentation. I'm very happy if you have any questions for my Jesus. I thank you so much.
Thank you very much, Dr. Viet. So I think now